Because of its high energy efficiency and low installed costs, variable primary flow has become the industry standard for water-cooled and many air-cooled chilled water pumping system designs. In this video, we will be reviewing an example water-cooled system to learn what a typical variable primary flow pumping system looks like. Additionally, to highlight the key components of variable primary flow, also known as VPF, there will be several comparisons made to the second most popular pumping system, known as constant primary variable secondary flow, or commonly shortened to primary-secondary. So what does a VPF system look like? Here's a typical design. Let's discuss the main components, the pumps, isolation valves, and the bypass valve flow meter tandem. Furthermore, you'll notice the chiller and air handling equipment. These components support the building load, but remain constant independent of the pumping design, so we won't be focusing on them. Okay, first the pumps. The two key differentiators here, versus a primary-secondary system, are that all VPF system pumps are variable speed, and they're all located upstream of the chillers. Whereas you can see in a primary-secondary system, there are two sets of pumps. They are located both upstream and downstream of the chillers, some of which are constant speed, the primary side, and some variable speed, the secondary side. This difference in design directly links to the higher efficiency and lower install cost for a VPF system. One additional item to note regarding pumps is that VPF pumps can be arranged in a chiller-dedicated design, meaning they directly support each individual chiller, or in a header design, which is much more common. The headered approach allows all pumps to contribute to the system flow, independent of the number of chillers. This is typically preferred by the consulting engineering community, as it allows for improved system energy optimization opportunities. For example, when the system is operating at part load, a control strategy could be implemented to optimally balance the load across several pumps to help maximize system efficiency. This is a more difficult task with a dedicated pumping arrangement. Our second system components are the automatic isolation valves. Their purpose is simply to open and close as building load changes. However, a key design consideration is that they should be capable or sensitive enough to maintain acceptable flow rate changes through the chillers. This means the valve should not open too fast or too slow, but as dictated by the building control system for each unique application. And thirdly, we have our bypass valve and associated flow meter. The primary purpose of this duo is simply to maintain the required minimum flow rate through any operating chillers. In other words, based on the system load, the controls could tell the valve to open and allow fluid to bypass the coils to feed the chillers. This approach is compared to a primary-secondary system, where again there is a common pipe as shown, but no flow regulation, meaning fluid is able to flow in either direction to balance the system. However, the unwritten rule with this design is that the primary flow should always be equal to or greater than the secondary flow for optimal performance. Therefore, the flow would follow the same path as a VPF system. Lastly, as an alternative approach to the flow meter, some sites will use the differential pressure across the chiller's evaporator to estimate flow. And this approach works, however the flow meter's accuracy is typically preferred, as it yields the best chance to protect building owners against unnecessary energy consumption. These are the basic components of a variable primary flow pumping system. Thanks for watching.
York, high performance environments for life.